was gonna say the conventional wisdom is that the AP is like 70% of all their sports reporting is all automated based on scores and things like that. So
yeah, and those earthquake, you know, anytime there's an earthquake, it always says this is auto-generated by the earthquake, system, whatever. Little article. Well, welcome everybody to the joint club meeting, RSSC and RRS and Tech Room. Welcome to our Saturday edition. I'm Jim, and we'll be doing just some basic announcements and quick business meeting, if anything, and then we'll move on to show and tell. So if you have anything you'd like to show and tell, please just put your name in the chat, maybe, and put like a couple of asterisks in front or something. So maybe that makes it easy. But yeah, it looks like we have some people. We were just talking about the GPT 3 that the GPT series, the GPT's J6B one, which you can download to your own computer and at least download the weights, but you have to have a really beefy video card or run it on a CPU. So I found it easiest to spin up a Google Code Lab, and you can run it from there, and they give you access to a TPU instance for free for a certain amount of time, and as long as you click the I am human every once in a while, you're using an incredibly powerful machine, and you can get responses. You can chat with this bot and get responses within 6 or 7 seconds. So that's pretty cool. But I guess we should go over the if there's any announcements. Next month we will be Riverside. The RRS will host this meeting, and then we'll be going back and forth between us, the RSSC and RRS every other month. And but other than that, no other schedule changes. As far as it's meeting in person, we're waiting for that, but there's no update as far as I know about. If anybody has anything, please let us know. Oh, someone's saying that. Oh, right. Hopefully we will not get Zoom bombed. So we're using a new link every meeting. So you have to look at your email to get the link. That may cause a few people to miss it, but hopefully people will get the message that you have to be on the mailing list and get that link. But we haven't had any since, so no more Zoom bombing. Cross your fingers. Yeah. All right. Any business item? Oh, and Ben Partisi, he's got a class in the early morning on Saturday, so he's probably not going to be able to make this one as the VP, current VP of the group. But he'll make the other one, the Friday one. I think the schedule's working out well with the Friday evening and a Saturday, so different people can make it who can't necessarily make one of those times. Although I think we get more head count on the Friday ones in general, it seems like. But I think it's still a good idea. If anybody has any opinions about the Friday and the Saturday thing, please let me know or let us know. anything from anybody else, or Alan? Do you have any university information, or not really?
Man, as it's the same in the university, just like it is in the general public. We're all kind of in this waiting game. So many unvaccinated people keep dying. We've got these new variants surging. Tentatively, we're still planning on increasing the population and going back to normal. But the reality of it is that we need to get more people vaccinated, and we need to curb this. So I'm not saying we're on pins and needles, but some days we're wondering if we're going to get shut down again, just because of the number of it. So yeah, we're in a holding pattern. I think that's the short answer.
The campus is open for for in-person classes with masks and all that, right? But
yeah, up to 40%.
40%.
And so I've got to be honest, it's really awesome having people back on campus after having it to ourselves for 18 months. So, we got all kinds of projects done. We never left. We kept the lights on the whole time. But it's nice to have people back.
Yeah, I bet an empty campus can be lonely. I would think, to some degree.
For sure.
Hey, Jim.
Yeah.
This is Camp. I just want to mention the silver lining of this is the Zoom and the meetings and the interconnections you get that you wouldn't get had it not been for COVID. But regardless, Homebrew Club's having our it's our 19th annual Phase 3 HPRC Challenge went last Wednesday, September 29, 7 p.m. Pacific time. So show up and show and tell. It's always a lot of fun. Join our mailing list, and it's good to see you guys on a Saturday afternoon.
Right, you're calling from East Coast time.
Yeah, I'm in Tallahassee, Florida. I'm on the East Coast. I'm on the East Coast watch here.
Yeah, that's good. It's good that times work out. Yeah, we definitely. I mean, I should definitely say that we do. I've appreciated. I think we've all appreciated the ability to connect via Zoom with with clubs like the Homebrew. And the other clubs from Riverside and everything. And it's
the guys in Texas. The guys in Texas too.
And the Texas, yeah, I haven't personally.
And that crazy guy up in Canada.
Yeah, so it really has opened up opportunities, and I hope we continue that.
Well, I'd say this to our folks is that from here out, there'll always be a Zoom segment of the meeting. I mean, it's just as simple as having a computer, in the meeting, and whoever, wherever, can log in. Not as good as being there, but it's close.
Yeah, as long as we'll have to see how it works. I mean, we'll try to. We've got some. Yeah, we discussed it last time about how to do that, how to do the model of having a Zoom. Essentially have a Zoom connection, even if you have a live meeting, and then you have someone at a computer with also monitoring a Zoom meeting, and then when everybody's watching, when there's a speaker, everybody's concentrating on the speaker, and then after that it breaks up into sort of two groups that are talking amongst themselves. And anyway, that I think we'll try to do that. But yeah, it's this point, it looks like, it may not be till the end of the year that we'll be in person, even probably November at this point and then you're at the end of the year, and who knows, it may be next year. Oh, well. Yeah, but yeah, we've gotten a lot done. We can do a lot for video, but we do look forward to the chance to have robots in person and be able to, touch them. So, all right. Anyone else have any announcements or information related to? Well, I guess there's not much business items. Any other announcements or anything that from anybody? Otherwise, we'll move into show and tell. And Yeah, Alan, why don't you go first, and then I'll go after you, or you know,
Oh, okay. Yeah, no problem.
because we're all excited to see, you know, a JPTJ6B running locally with no internet requirement on your machine and no cloud services.
All right, let me just make sure we're sharing the right thing. All right, can everyone see the workbench?
Yes.
Yeah.
Is that up? Okay. All right, so this was a quick conversation I was having just to make sure the microphone and speakers worked when I was logged into Zoom. Go ahead and reset that. So GPT-J is the open source version of the small version of GPT-3. And basically the whole thing between the transformers and its use in natural language processing is to predict the next word based on the patterns it's learned from a giant corpus of text. So you can give it a prompt and then it'll continue writing the rest of the article. What I've done, and this is based on CentDex's recommendation from last month, is to treat it like a chatbot. So provide it structured input based on a human and a bot, and then it'll pick up on that pattern and hopefully engage you in a conversation. What makes this a little bit different from other chatbots is that after every response, you feed the entire conversation back in as input. And so what's cool about that is that if you're on a roll, there's a fighting chance that you will actually have a relevant contextual conversation. And it's not always 100%. Some of them are duds. So what I've done is I've taken that concept and I've paired it up with NVIDIA Riva, their automated speech recognition and their speech synthesis module. And so if the screen's keeping up, what you're seeing in the prompt is the intermediate and final automatic speech recognition output from their speech recognizer. So it's as it goes. Yeah.
What is the name of this program?
This is from the NVIDIA Riva package.
Oh, okay.
Yeah, so they have this big old Docker file. So you have to learn learn Docker. And then once you figure out Docker, you can download and run the Docker file. It connects to your graphics card. And it gives you all of these tools that are supposed to be building blocks for voice things, voice services, chatbots, whatever. So the way I have it set up is that as it's listening to me, it's making a best guess, and it'll place that best guess in parentheses. And as soon as you stop, oh, here, let me do it. And as soon as you stop, it takes a split second, and then it'll run it through a formatter and give you a fully formatted version of the text.
Very fast, Alan. Very fast.
That is super cool. So all I did was I took this module and I plugged it into the chatbot, and I said, hey, as soon as you have a full statement, go ahead and feed that off as input into the chatbot, and then run the output of the chatbot through the WaveNet speech synthesizer module. So let's go ahead and do a quick live demo.
Hey, Alan, is this you crafted a GUI here in was it what did you use for that? Is it Python?
Oh yeah, it's this is all in Python. This is PyQt5 UI that I slapped together to give me more control over testing it. Because when you get started with GPT-J, you write a Python script and then it loads up the model and then it does something and then it exits. And that it takes about a minute to load the model up, which is great if you're toying around with it. But if you want to iterate quickly and put in prompts, you want it to run in the background resident. So in this monstrosity of a program, I'll load up GPT-J in the background, and then I've set it up as a gRPC server. And then I set up a gRPC client that'll pass input over it asynchronously so it doesn't lock up the UI. And when it gets the response back, it populates that response in a queue, and then that's added in. Anyways, it's real time. So yeah, let's give this a quick shot. Let's run it live. We'll see if we have a good conversation.
Alan,
Yeah.
I don't want to hold this up too much, but you threw out a few GP somethings there, and I didn't quite.
Yeah, he said gRPC. I'd like to know that one too, but what is that one, Alan? The gRPC, is that a it's a server client relationship? I know we're.
Yeah, no, it's a good question, because there's a laundry list of things I had to figure out to make all that work. And as proud as I am of it, most of it's boring boilerplate. But this is one of the things that, let me find the website, and then I'll walk you through what I've been able to figure out about it.
I guess, yeah, you could, it's up to you. You could do that first before demoing. Oh, it's also a college.
Well, it's a live demo.
So the when
okay,
you run through NVIDIA Riva and you download the Docker file and then you run it, it runs as a virtual machine, kind of in a background, right? That hazy area between a full virtual machine and a sandbox. And the way you communicate with all of the modules that it loads is through gRPC calls. And so when you're translating audio into text, it sends packets of audio out asynchronously, and then it through the gRPC, which is a Google thingy.
So gRPC, I recognize it now as a programmer. Remote procedure call is what RPC means. It's for remote procedure calling, functions remotely, and the G means Google, right?
Correct. Yeah.
So it's Google.
You had a GPDJ earlier or something. What was that?
Oh, so GPTJ is the open source
TJ, Tango Golf
model.
Got it.
Yeah. Version of the GPT-3 transformer that you access through an API, and then they charge you for access to if you're a developer. This is a version of it that's been trained on an 800 gigabyte corpus of text called the pile. And what's cool about GPTJ is that they've released all the code and the trained model. So you can run it in a Google Colab. They're just finishing up the pull request to add it into Hugging Face, so you can download it through Hugging Face. And with a little bit of tweaking, you can run it on a 3090 back on a personal computer. So to figure that out, I'm sorry. Oh, Hugging Face. Oh, this place is awesome. So Hugging Face. Hugging Face is kind of like the Thingiverse of Transformers. So it's no one seems to like the name, but it's catchy. Like, you can't forget it once you hear it. And here's where you can download different transformer models and for
Alan, what's a transformer? I know what the robot is, but I don't know what this is.
So the transformers are the type or style of neural net that allows for these types of natural language processing, fill in the blank, find the pattern in the prompt and extrapolate type of neural networks. So it works with text. They're trained on a large amount of text. And then with the right model and trained correctly, they can pick out enough patterns to be able to continue that pattern based on a prompt. So there is a large amount of models that are already hosted here, and it's a good place to check out. They've got information on how to use it. The transformer module is just a pip install transformers. And then with a few lines of text, you can download and leverage a large number of transformer models from different people that you may have read about in the news or in papers. And one of the ones that they're almost ready to release, Luther AI, GPTJ, is, and this one's almost ready, is you can use this site to download and use this powerful model with 3 lines of code. So that's what's the cool thing about Hugging Face is. sorry, and a long list of things to get from point A to point B.
Oh, so you'll be able to do this once it's launched?
Yeah. So in the background, I have a gRPC server where I'm loading this up, and then I'm setting up a gRPC endpoint that looks for requests for text, and then it processes it. When it gets it, it sends the response back out on a gRPC message. And that can happen asynchronously compared to the rest of the UI. So the UI doesn't lock up while it's waiting for a response.
So you actually have a queue then, you said? So you can actually, well, obviously when you're talking to the bot, you kind of have to wait till it responds to communicate. So, but your UI doesn't lock up. So, but you kind of do have to wait unless you want to send it something without waiting. I guess you could, right? You could say, hurry up.
Yeah, and so it's like there are so many fun little challenges with this toy program. Asynchronous calls and responses, making sure the UI is responsive, making sure the UI doesn't lock up when it's waiting for a response. All these little things and queues and gRPC calls that you have to leverage to make it work was I don't want to call it an experience in frustration, but it was enlightening.
Yeah. Okay.
So here, let me get back over to the workbench here. All right, so let's do a quick live demo. We'll turn on NVIDIA ASR, and we'll allow it to submit the prompt as soon as it has a fully formed sentence. So I'm going to check this guy off right here. Good morning. What have you been up to so far today?
I went to work and I did not do anything special.
You went to work? What kind of work do you do?
I am a software engineer. I make programs for computers.
Oh, that's great. So do I.
So do I.
All right, so what should we work on next?
Well, I am not really sure yet.
Well, think about it and let me know.
Okay.
Let's talk about robots.
I would love to.
What is your favorite robot?
I like the C3PO.
He's one of my favorites too. What about R2-D2?
2.
Yeah, that prompt didn't make much sense. It doesn't, the ASR doesn't know how to process R2-D2. So it comes out like that. You know what? I don't really like that response. So let's go ahead and ask for a do-over.
No, that was great.
So yeah, it's just a fun little toy to explore it. I'm working on a second piece of the UI. So this whole UI is set up conversationally, and you can set up the prompt to start out wherever you want. And I know I already mentioned this, but one of the coolest things about this version of a chatbot is it feeds all of the previous input and responses in as input up to 20,048 characters. So the chances of having a contextually relevant conversation is so much higher than on the other chatbots, which are one shots. If you ask the same question, it gives you the exact same response again. This one actually, it's highly variable. Yeah. So let me show you how much it can vary with one quick example, and then I'll.
Alan,
yeah.
Do you have your monitor and speaker plugged into, what is this, an NVIDIA Nano or something?
This is running on a graphics card that I have on my computer.
Yeah, you should give if you want to know the hardware, maybe Alan, you could tell them your setup briefly.
Oh yeah, for sure. So on this computer, I have two NVIDIA RTX 3090s plugged in. And so I have NVIDIA Riva running on one of the graphics cards, and it takes up about 12 gigs out of the 24 gigs of memory. And then the GPT-J model is running on the other card, and it takes about 14 gigabytes out of the 25 gigabytes of memory. It's a little crazy.
Yeah, so just for everybody's understanding, these two cards, you're talking over $1,000, probably $1,500. You know, even in the scalp market, they're 1,500. They were $1,500 each. And now they're like maybe a few thousand each. So this is in today's equivalent, it's a $5,000 worth of hardware right now, right, Alan? Something like that.
I don't know if I'd put that fine a point on it, but yeah, it was. They were
4,000?
purchased in anticipation of working on stuff like this, and I'm super excited that these so just compared to last year, it's like sure there was code available and if you were a master in the ways of Python and that you could get it to work, but check this out. All I had to do was figure out Docker, and I have access to real-time speech recognition and speech synthesis. As soon as someone tipped me off to Hugging Face, a couple lines of Python code, and I can download one of the most advanced models in the world. What a time to be alive.
Yeah. Oh yeah, it's great. It's just, yeah, I'm impressed at the speed. Did you improve your initially, wasn't it like 10 seconds or 8 or something like that? How did you get it down to like really real time there?
Yeah, I wish I could take credit for that, but it was just a matter of Googling at the right time. The original model that was runnable on a 3090 was set up using JAX, and the inference time on that for 42 tokens was about 8 seconds. Yeah. And it just so happens that while I was playing with that, someone way smarter than me was off to the side saying, hey, let's transform this model into something that's runnable in PyTorch. And oh, look, there's an option in PyTorch to cut the cut the resolution in half and get similar results. Well, when you do that, it actually makes it 4 times faster.
Oh my.
And so that's the one that I've been running. And
Alan,
yeah.
I can see it still listening to you.
Oh yeah. Yeah. I'm just going to let the ASR run. I'm just not going to let it submit the prompt. So I have this one unchecked, but yeah, the speech recognition is, and this is pretty impressive for what it is. The part that it's harder to demo, so you'll have to trust me on, is that I can leave the microphone hot on my desk in my office with all these fans running, and it is just as accurate. So it doesn't necessarily need to be a microphone next to my face. It is very good about separating out voice and speech from the background noise, and you get very similar performance even when it's a mic across the room.
Not creepy at all.
And that's all local, right, Alan? Nothing in the cloud or the web or anything.
Correct. Yeah, everything you're seeing here is running locally.
That's nice. Nobody has to listen in.
So are you saying doing this in the cloud's more economical and doable versus what, $3,000 or $4,000 worth of hardware?
Well, I'm just saying that, I mean, if people can try this out using the cloud, like I could demo that actually later because I have everybody can use.
That was what I was asking. Is you could do this without,
Yeah, you can try it out, but it's not nearly as fast. It's like 6 to 7 seconds, but you can do it. But yeah, if you can get your hands on the hardware eventually, boy, it's pretty amazing.
Yeah, it's kind of like a glimpse of the future to me. It's like, okay, in a couple of years, this is going to be in everyone's pocket kind of technology.
Alan, are you spending a lot of money because you're not making a lot of money mining? You took this mining rigs?
So that was the other reason I invested in a couple of cards. So whenever I'm not playing with the deep learning stuff, they're earning a couple of extra bucks on the side. And then whenever I want to do things like this, I'll just turn that off and I'll use the cards for something else.
It's a dual purpose system then.
Yeah. Yeah. So here to wrap this up, I think the last thing I want to share with you guys is that the responses are variable, meaning you can put the exact same input in and you can get 10 different responses out, which if you're looking for predictability can be kind of frustrating, but I just get such a big kick out of it. So I'm going to run through one more prompt and then we're going to do a couple of do-overs to see the variety of responses you can get just from one. So let me get this reset. Good morning. What have you been up to so far today?
I'm currently working on a bot that will be able to make jokes.
Okay, that's one response. Let's ask for a do-over.
I've been playing with my new robot friend, Bob.
All right, let's ask again.
I have been working hard and trying to help you get through the day.
Good, that's good.
And then
I
one
am
more.
looking for a job.
And so it's as entertaining as this is, and I don't want to admit how long I've been sending prompts through it, just having fun with it. It is a statistical conversation. The previous parts of the conversation provide context and clues for words that it'll choose to continue the conversation. After the conversation concludes, there's no memory of what that conversation is. The conversation is based on statistically what it's seen in the 800 gigabytes of text. It may or may not be related to the truth. You can ask it questions and sometimes get a direct answer that may or may not be accurate. But for every conversation that I posted up on the group that just blew me away, there were 4 or 5 that were either mediocre or weird. I had one that I did not post, but we were talking about vaccines, and it in that iteration of the chatbot, it was apparently my chatbot was an anti-vaxxer that insisted that vaccines cause autism. So it's the responses are non-deterministic. You don't have any control over them. When we were talking about that LEQ robot for the elderly that I posted a few weeks ago, my new litmus test is, would I trust this chatbot talking to my mom? And the answer is no, because you have absolutely no control over its intent. And you can have some really dark conversations if you want to, because it's just matching up the patterns of your input with existing patterns in its corpus. And one of the things that Les posted last week, I should respond to it. It was a great opening conversation. This knowledge, this body of information that is being used to generate text, took a pod of 256 of the fastest AI accelerators known to man, 1 week to crunch through and generate, right? So there's a training phase, which as an end user, if you wanted to purchase that time of Google Colab, would probably cost $100,000. But then you can use the results of that training data to run inference. This is what we're doing right now. We're using the model that was generated. Now, let's say for sake of argument, I wasn't happy that my model had stuff in it that was talked about how vaccine caused autism. Now, there's no way to get that information out of the model without retraining it right now. And I don't know about you, but I don't have a spare $100,000, to run it through Google Colab. And it's a very interesting challenge right now. So we have a snapshot, a crystallized moment in time of a distillation of knowledge from a piece of information. And then we have something called fine tuning, where you can customize it and add in little bits of information for specializations, but we have no way of taking that information out. And I'm very excited. There's a bunch of people working on that, and I'm very excited to see what they figure out over time, because just like you can't backtrace and ask the AI how it came to that conclusion, there's no way to tweak and remove data once it's been quote unquote learned. Very interesting.
That's a very interesting thing. It is a snapshot. So if there's at the time it's done, if there's lots of controversial information, it captures it. Yeah, so it's kind of a, to be honest, it's kind of a reflection of our entire society, all the good and the not so good. So,
you got garbage in, garbage out sometimes, you're saying, right?
Yeah, I mean,
the internet is not necessarily a source of truth. It's just a source of words.
Yeah,
put it on the internet. It must be true.
Exactly. Think of all the.
If I can get my 2 cents worth here, this is something that I've been researching recently, and I found that most of the time when you train a model on a corpus of data, and I've been using GutenbergPress.org, it ends up just doing a deep learning model of what's essentially a Markov model. And so if you implement the Markov model, it's about 1,000 times faster than the neural net model, and you get about the same results. So I have something very similar, and it's running on a Raspberry Pi 1, and it's fairly instantaneous, and it doesn't require training. One of the other benefits is you can, because you now have direct access to the Markov model and the data that you fed it, you can get rid of the hate speech and the anti-vaxxer speech because it's no longer opaque. You have exactly all the information as to what the statistics are showing you, which phrases are going to follow other phrases and which ones are more popular. So I had a demo that was basically just about 12 lines of C code with a simple Markov model, just first order linear. And I did it mostly as a challenge because my girlfriend was looking at horoscopes. And basically I said, you know, I could quickly write something that if you give me a bunch of horoscopes, could just crank them out and you wouldn't be able to tell the difference. And that's what kind of started me down this research. But interesting stuff.
Right, you'll have to share that if you're claiming this is really fast and actually controllable. That sounds really worth our people.
And if I'm understanding you correctly, the based on using HMM instead of deep learning is that there's no real training, that it pulls based on something else from your corpus of data, and you can prune data out. And then the next time it generates a response, it doesn't include that data. Is that correct?
Well, technically there is a little bit of training, but it's not the type of training you think of with deep learning. It's very quick, it's linear, it's order n with the corpus of data that you have, and it's just building up the Markov statistics with a single pass over the data. There's no deep learning going on. It's something that you can do on a Raspberry Pi or an Arduino.
Can you show that? Do you have any demo of that?
I can show you the real simple demo. Let me share my screen really quick.
All right, yeah, well, since this is part of the same topic, if the other people who want to present don't mind, maybe we can do this now.
No problem. No problem.
Can we see my screen here? Sorry, I only have one screen, so.
You'll have to, you have to hit the share screen. I think everyone's allowed to hit share screen, but I don't see it yet.
I'm sharing screen. The share button is grayed out.
Oh. Alan, do you have to allow sharing for, mine is green.
I have it set up so all participants can share. Yeah, I'm not sure why that wouldn't work.
Let me try again. I'm clicking share screen, and share's grayed out for me.
Wonder why that would be. You might want to try disconnect and reconnect. I don't know.
Yeah, I'm sorry, Chris. I'm not sure why that's happening. Are you joining through the application or through the web client? I'm just trying to figure out what might be different.
I've done this before on the web client. Interesting. Anyways, I can post something to your news group. It's a really simple C program that you can just run in Visual Studio. And I only grabbed one data file from Gutenberg. I forgot what it was. Sorry, I can't share my screen. It's not nearly as impressive as yours. It spits out mostly gobbledygook. And again, it depends on how much data you have for it to build the Markov model from.
Right, so if you have a lot of data, like gigabytes, then it's going to be quite different.
Yeah, so Chris, here, I'm going to post a link over into chat in case this is something you'd be interested in. The GPT-J is trained on an open source corpus that they're referring to as the pile. It's 825 gigabytes, and while I don't have the resources to train a GPT-J, I was figuring it out on my two cards. It would take almost 2 years to do it. I would be very interested in applying the hidden Markov models to something of this size just to see what would happen. You know what? A lot of stuff gets me excited nowadays, but one of the things I'd be excited to explore as part of this is that problem that had mentioned before, is that once a neural net is programmed, there's no pulling information out. But after training the HMM, if it's as simple as going through and find and replace or find and cut through the corpus, then that could be potentially very interesting, not only as a replacement, but another tool in addition to this, you know, as part of that stack of cool pieces of software to get a robot to do something interesting.
Yeah, that is cool. I'd like to download this and see how fast the Markov model gets built from this.
Yeah.
Yeah, I grabbed all my data from Gutenberg.org. There's, I don't know how many terabytes there, but what's cool about that is you can grab your favorite author and start generating stuff based on what that author might write. And you can pretty much build whatever models you want. And I'm of the mindset, I don't like deep learning. I think it's lazy programmers, because they're using a tool and every problem looks like a nail to them because all they have is this one hammer. And there are much better AI ML algorithms out there that are faster, that are more targeted to the problems that you want to solve, rather than using this one big hammer.
Yeah, for sure. Sometimes it feels like a fad, because we've all lived through, what were all the ones? Someone mentioned psych a few weeks ago, but you know, every time they try to codify knowledge in a certain way and explore limits and extend beyond that, it's always fun to see how far they can go, and you know, if they don't do so well. In one of the talks that I'd given a few years ago, the way that I see it, the way that I explained it, was that back when deep learning was younger, and before we had all these great breakthroughs, was that there's kind of a fork in the road. And it's actually not a fork anymore. I think it's going to be a bit of both. Traditional structured programming versus a trained deep learning style approach. And this just gives me a chance to dip my toe on the other side. And it's kind of fun. You know, you can do a neural network for just download from Hugging Face for sentiment. Is the input negative or positive, right? So yeah, no, I'd love to take a look, and I'm doing a Google search feverishly in the background to see what other stuff is out there with HMMs and NLP. But yeah, I'd like to take a look. That sounds like fun.
Yeah, we're all new to this, so we haven't formed any strong opinions about what's, you know, good. It seems pretty incredible, these transformer models. So we're still excited about them. But if there's other things, we definitely want to, you know, your research will help us definitely, you know, find more solutions.
Huh.
Cool. Well, I'll put something together for public consumption and post it to your news group.
Yeah, thank you.
That. Thanks.
Yeah, anything, you know, that sounds very helpful.
All right, that's all I've got. Thanks, guys.
All right, so in that same spirit, I was going to show the collab. I think I haven't run it in a while, and it looks like things have changed a bit, but I can just show you what it looks like, and then if I get it working later, I posted the link. I might have to, something may have changed somewhere in there. I don't know, in the things that it downloads. But essentially, you'd be able to click a link. Goes as long as you have a Google account. That's the requirement. And if you have a Google account, then you can get use of one of these Google Colab TPU instances, and it's a full piece of hardware up in the cloud, a pretty powerful machine, and then it will do pretty much what Alan's thing is doing, except for this is a chatbot where you type. We're not talking about any of the speech recognition. This is just a typing chatbot and printing back the response. But this is what a a collab looks like. And it's a web page. I just clicked on this link that I shared, and I gave some actually, I should send out the email I had sent originally. I'll send that out again, but there's some instructions to get this to work, but it's pretty easy. You just like say run all, go to this runtime menu and say run all, and then it spins up a system here, and installs everything. So it takes a long time, 15 minutes or something like that. But once it's going, and for some reason I'm getting an error right now, seems like something changed. But at the bottom here, I wrote a little program to do the actual chat interaction. So when this runs properly, you'll be able to type here and you'll get responses from the system, from the same exact thing, the GPT J6B inference. And so I'll try to get that working again and update. So don't try it today, but that link should work. Hopefully I'll get it working again. And then anybody can try it as long as you have a Google account and have 15 minutes. And once you've waited the 15 minutes, then you can keep talking to it. I mean, not talking, typing to it. And you may occasionally have to click a I am human button because Google is wondering if their expensive time sharing is being used by a person. It's only allowed for, for people to use live for a limited amount of time per day, that kind of thing. But it is available, which is cool. And then, yeah, once you do that, it's about 6 to 8 seconds for a response. So it's much slower than what Alan has, but it's usable and you can just check it out. There also is a web interface, like Alan was showing, to that GPT-J6B. Maybe Alan, you could post that web interface link. I think I've done it before, but that isn't a chat like I've set up in the collab. What I've set up there is an actual sort of chat interface, a crude chat interface, whereas the link he's going to share with you, the official web link to that, it's just the raw inference engine, and it's not really a chat. So you could try that out too, but it's not, it doesn't have it doesn't have the flexibility of a little program you can write with that collab. So is there any questions about that? I'm going to show a video of a totally different subject next. So, but if people are interested, I'll fix that that collab file. It's in my Google Docs, and it's publicly available. It will be. Permissions are set to anyone who has the link. Then you can all talk to it. For the okay, so there's no questions. I'd like to switch topics here and show you. We didn't get to it last time, but our team, the social distancers, including Brian Erickson and Carl Sutter and Justin, Brian's nephew, and Dr. Bruce contributed, and myself, and to the Open CV AI competition. We spent like 5 months on it and worked on using these OAK-D cameras, the stereo AI cameras. So I'll show you the video here that is the result of our work. And I mean, I was able to get the furthest just because I really already had a kind of a personal assistant robot underway, and the other guys were working from scratch. So it's it was lucky that I had that already, you know, in the works. And the quality was really good of the API for the OAK-D and the OpenAI, and they actually fixed things as we were going. So here we go. I can talk over it too. So yeah, Brian as well did it, and Justin did a robot, and you can see that the OAK-D is the camera there with the three. It's got stereo lenses. And the first two robots were ROS-based, using ROS 1 though, because we didn't have time to really do any, you know, deal with ROS 2 at the time. And here's the orange demo.
Orange, take this to Jim in the office.
Okay. I'll come get it.
So the top camera is used for identifying people and objects.
Please place the object on my tray. Okay, I will take this bottle to Jim in the office. I'm going to the office.
And this is using the previously done work with the SLAM Tech and the mapping system that's already there. Obviously with a pre-done map. And navigation through the SLAM Tech API. Here's where we use the depth map to go around an obstacle. So it generates depth maps, it publishes them, and then they're integrated in the analysis of the, or for the planning of the path planning. And here I have a search algorithm to go in a circle, look for a person.
Hello, Jim.
And then it plots the course to the person using that depth information.
Jim, I have a bottle for you. Please take it.
Thank you, Orange. And it can recognize when
You're
the bottle
welcome.
is taken,
Enjoy.
put on or taken. Orange, where's the remote? Here I'd use a different search by moving the
I see a remote.
Actual servo-based control of the camera, the pan tilt.
I found the remote.
Thank you, Orange. As I was saying, unfortunately, it doesn't have an arm. So there you have it. I have my water and my remote. And we thank all the people that were involved. Special thanks to Dr. Bruce and all the team members.
That is so stinking cool.
that's a bit of work. It took a few months to, well, it was pretty much a dedicated for about 5 months on, working on the whole thing. And we met every week or almost every week or two for an hour or two on our in a Zoom, just like this.
Big orange rocks.
Thank you. So yeah, it's the results are the contest results are going to be published in early September. I think it's like the 9th or 10th, second week. So we'll find out if we how we fared.
Jim, very, very impressive. What was the most challenging part of this project?
Yeah, good question. The really getting the reliability of the software to work, writing these algorithms, essentially the reliability and filtering. I'd say filtering was pretty challenging because when you have these sensors are like the camera is giving you information per frame, like 1/30th of a second or something. And if an object is seen for 1/30th of a second, or not seen for 1/30th of a second, you can't use that very effectively. You need to know over time, like the way we integrate with our brain and our eyes and our brain, we integrate over time. That object is there, it's staying there. To a robot, to a camera, those concepts don't exist. And through the APIs they provide you even don't have that. You have to keep track of something that's there for how many frames and consecutive frames or whatever, or certain percentage of time it's there. And then, so I had to write code like that. And then the logic.
It was just like the lower level sensors we use, and you have to do averaging and low pass filters. You were surprised to find you have to do the same thing with the image detection, the YOLO and things like that, because it'll be, face will appear, disappear, or will appear or disappear. So you have to give a low pass filter. So you decide, is there really a face there?
Right, low pass filter. That's the key.
Is this done in OpenCV?
Yeah, well, the main code is, OpenCV is part of the solution. What runs on the camera is a pipeline for inferencing, but not OpenCV. That runs on the computer part of it, the CPU. But the camera actually runs a pipeline it's using the Movidius processor to do the AI and the recognition. And we use OpenCV to do image manipulation, to do some image processing, after sort of a post.
So once the data comes out of the OAK-D, which, as I understand you saying, is using the OpenCV, how are you dealing with it in C++ or Python or what?
Oh, I'm using actually both really, but mainly Python. Both interfaces exist. I had to write a C program that uses the same thing. It uses gets the data from the camera and does some OpenCV. And I wrote the Python version too. The C version is to do the depth mapping and publish it to the SlamTech, which is the C interface. And then all the recognition, the higher level robot behavior using the depth data is all in Python. And they have examples for both in their API, the OAK-D software. So
the camera
do both.
The depth map, though.
What's that?
The camera actually gives you the depth map.
Yeah, I had to, it gives you a depth map. You can, there's multiple different resolutions. It's using disparity. So you can actually get the disparity, which is the actual measurement between a pixel measurement between the left and right camera of any particular feature, the system will automatically match features that's built in, and then it can give you a directly depth map and at different resolutions. Then I had to convert that depth map to a form that my system could handle, which is just a minor conversion really, and scaling and stuff like that. You can use OpenCV. But that's just cool. Yeah, it uses disparity and it does pattern matching internally to the camera. You can also get, the disparity directly and do the computation yourself, where it's already done the pattern matching for you. That part you never have to do yourself, because to do stereo, to get a depth, you need to know, is this the same point on the image on the left as the right? And that's a complicated problem. And that's done for you in this system, in this stereo depth computation.
Camera quality figures a lot into that, I found out.
What's that? Camera quality?
Yes.
Yeah. So that's another thing. These cameras are calibrated at the factory, and you can recalibrate them, but I didn't have to. I mean, I didn't bother. I'm like, this is it's near a commercial product. It's just kind of an early thing, so it should work. Thank you for the comments, Danny. Any other, did I answer the questions? Any other?
Yes, very well. Thank you, Jim, for clarifying all of that.
Yeah, and there's all the source code is on GitHub, and we will probably publish that report on either GitHub or on I'll send a link to it, because we have our report that we submitted is a written report with pictures and stuff.
What GitHub?
What's that?
What GitHub?
It'll be
what GitHub to go to?
It's my GitHub, my personal GitHub, and I can post that right now if you'd like. Here, let's respond to everyone. So yeah, it's like, did that come out or?
Yeah.
Looks like it's cut off on my screen.
Yep.
It is. It's the hub. Oh, there's.
Yeah, and so there's a report. This is a mix of different code, and thanks to the SlamTech people for providing a good platform that did a lot of this technology, already for navigation and stuff. All right, well, I guess that's it for me.
I wrote a question in my.
Oh, I'm sorry, I didn't.
It's okay, I'll ask it. I was wondering if when Orange left the kitchen and went to the office to deliver the water bottle, it specifically looked for you. If you were not there and say someone else was, say a man who's of similar height or whatever, but not someone who looks exactly like you, obviously, would it be like, oh, Jim is not here? Or would it give the water bottle to that other person?
Yeah, in short, at this stage, it would just give the water bottle to any person it finds. We didn't get to the point where we're trying to do a personal identification of an individual identification. This was there just really wasn't enough time to get everything working. That's a good future enhancement, but in this case, we're using a part of the human detector essentially. So it can detect a person, and that's all it's doing in this case. It doesn't matter who it is. And there are already models in there that you could download that can narrow it to a certain age and sex, like female age 30 to 40 or something. You can do that, But this one, I didn't use that model. And we do have some technology to do individual recognition that's been given to us. Dr. Bruce, I think, gave us some. And then you can also train the system which they have examples of where you can train it on particular individuals then in your house or something, then it could recognize if it's one of them or not. But you'd probably have to, it wouldn't, if it was somebody it didn't recognize, it wouldn't be able to, it would just say, that's not one of the ones I know. So that's possible too, but that's a future, and again, a good future project. And that would involve some training, which is, I didn't get into any training on this, which you can do. You can train your own model and upload it. And there's instructions, and there's even a free service that we got like a certain number of hours, 200 hours of free training time, whatever. But it is kind of labor intensive, I think, the way they're talking about it, where you have to go through images and say, this is so-and-so, and this is so-and-so, and repeat it over and over from video feed. And then you do that, and it goes into this training system, and then it learns. Essentially, you're training a model, and with a GUI and everything. Basically, you're doing the labeling. You have to do some manual labeling, and then you can do it. That's one way to do it anyway.
Awesome, thank you.
Oh yeah, there's the other. Yeah, so there's a ROS solution as well that was underway by the other teammates. And Carl posted that in the chat. All right, well, great. And okay, so I guess that's the last question, right? So next, I think so thank you. I believe next would be Camp.
Me? Okay. I'm gonna do my quick demo. Everybody see my demo, but this is on the bot vac, which is a robot vacuum cleaner. And basically, it features a LiDAR, two-dimensional LiDAR, spins at 5 hertz, takes 360 snapshots per revolution. I've got the Raspberry Pi inside the dirt bin. I've posted my GitHub, and that's got the code to do this stuff with. And so there's the robot. Let me share my screen. This is ROS 2. And I drove around and I made this map, okay? And so now I'll just navigate to the center of the hallway there. You see the robot going. Nothing up my sleeve. Map's off. This carpet stick, so you see some, it's not, the localization's not so hot. So I'm gonna spin around here one time, teleop, try to get that localization back. Point press, sorry. Oh, this is our visit. You haven't seen it before. It's all three-dimensional stuff. And there you see the LiDAR scans from 4 inches high. It's a two-dimensional LiDAR. So now I'm gonna navigate, point press, drag mouse up, and the robot will navigate into the bedroom.
Hey, Camp, is this ROS 1 or ROS 2?
It's ROS 2.
Could you do this in ROS 1, or is this a ROS 2 only sort of thing?
Well, here's the deal, Thomas, is if you're working on a project that's already ROS 1, go for it. But if you're starting something new or just getting into it, go ROS 2, because ROS 1 is end of life. And you want to skate to where the puck's going to be, okay? And it's similar enough. It's the same concepts and stuff. And so, and it's not like, none of this is done, okay? It's got a long way to go, which is a good thing because, you know, once it's all nice and smooth and pretty, all the goodies gone, right? And so here we are. So there's the robot navigating out. I have another quick show and tell here. Let's see here. Here's the robot coming back. See if I can coax it back into the bedroom. And let's go here. Here comes the robot. So, and I have one other show and tell, and that's this guy here. This is Herbert the robot. Oopsie. Let's see here. So the bot vac made it back to its goal. I'm going to just drive him off into the hallway there. Let's see here. Okay, so there you see Kerbit. Let's turn off the screen sharing. Okay, and let's see here. This is my Robo Magellan robot. Robo Magellan's a contest where you're given a GPS coordinate and an orange cone placed on it, and you traverse like a 100-yard playing field with obstacles and benches and trees and people and all kinds of stuff. Anyways, this platform here, I'm using the Huffy Green machine. It's a differential drive, pretty sweet tires, huh? I currently have it hooked up to the Arduino, and I'm controlling it with an Arduino. And there you see the wheels go forward, reverse, clockwise and counterclockwise. And I'm gonna plug into the Arduino here and just download some code. Let's see here. Bear with me. Let's try this one more time. Oh, is that not showing up? Let's try a different serial port. Well, that's more better. This is downloading the GPS code. This is a, I think, Super GPS from Adafruit, something like that. And let's look at serial monitor. Let me give it one more try here. 7 and 8. Try that.
Are you trying to share the screen, Camp? Or you're not, are you?
I am sharing the screen, aren't I?
No, I don't see it. Wait.
Okay, good, because I'm having trouble connecting and getting the stuff. I'll switch right over. Hang on a sec. I've done another upload here in serial monitor, and there it is. And now let me share my screen again.
Oh, that's just.
Oopsie. Damn it. I just killed it from being able to share my screen. Anyways, the point here is that I've got a GPS. I've got the Kerbit based on the Huffy Green machine running here with differential drive, forward, backwards, clockwise, counterclockwise. and I've got a GPS on here, and there I'm getting the data from the GPS. And I've got a version of this that just gets the bearing. So the idea is that the bearings from 0 to 359, 0 for north, 180 for south. And I'm committed to get this guy tracking north by our challenge meeting on August the 29th. I did mention the Homebrew Robotics Club is having our 19th annual HPRC challenge. Bear with me.
You mean next month, right? September 20? Or
I can't share my screen. That's right. I've disabled myself from it. Anyways, yeah, that's August 29. So bring your robots for their homebrewed robots. We always have a good time. Thank you very much.
You said August 29th. That's tomorrow. You mean, don't you?
I'm sorry. It is September. Next month meeting. You're right. We meet the last Wednesday every month at 7 p.m. Pacific time. So that would be September 29th. Join the Homebrew Robotics Club mailing list too, amongst all your other robotics mailing lists.
Yeah, I didn't know about the Texas one, or I haven't done that one, but okay.
Yes, you have.
Or maybe I have.
That Ross 2 meetup with Chaz is
that's technically. Oh, right. Okay. God, you don't even know what state you're talking to nowadays.
That's what I'm talking about.
Yeah, I've been joining the Ross 2 weekly meetings on, I think is it Tuesdays?
Well, there's one tomorrow, right?
Yeah, I'm sorry, Sundays.
Yeah, this is a Sunday meeting, and it's 1 p.m. Central Time.
Yeah, so here it's 11:30 in the morning, and it's good time. I mean, I've been joining that. I finally have some time I wanted to, spend on that, and it's very good. I love Chaz. I've heard of him before, but he gives almost very informative lectures or talking. It could be called a lecture, but then it's a free form open.
He's a software AI guy.
He's a software AI guy.
He's from France, in Texas.
Oh, really? Okay. But yeah, it's just, he accommodates new people and people who don't know Ross, as long as pretty effectively. So I recommend it if you want to get in. It is definitely, it can be pretty advanced, but if you want to get into Ross 2, it's definitely a good, it gives you a lot of good links and to start reading about it. And I'm starting to go through all those.
You get exposed to all the words.
Yeah, even if it's over your head, you can still enjoy the what's going on. The demos and and also the information and the links, and then you can study later.
Jim, can you post that in the chat, please? The address, the.
It's a the Meetup. The Meetup. It's done through Meetup.
I'll find it, Jim.
If you want to do it, that'd be great. Yeah. Well, here. If you want to do it, that'd be great. Yeah. So moving along, I believe Thomas. I think you were next. That you want to show something, and then after you, I believe it's Les.
It's Les H.
Les H.
Yeah, I used to work with a company where there were 3 Les's. So we were Les H, Les S, and Les D.
That's funny. That's a lot of Les's.
More or less.
Mostly more, unfortunately.
All right, I have just a very brief PowerPoint. I had a question from Dr. Bruce. I was hoping he'd be here today, and obviously he's not here unless he's hiding in the eaves here somewhere. I don't see him. He asked me some questions about my robot. My robot, for those of you who have been living under a rock, my robot's name is Simone. She's a fembot. She has artificial intelligence. I've made an effort to model her at least functionally off the Leaf robot of past, if some of you remember Leaf from several years ago. If you don't, you can look it up. Anyway, so these were to answer some of his questions, and maybe he'll watch this video and get his answers. Otherwise, I guess I'll have to write to him on the email list. So let me share my screen. And let's set this up. Okay, tell me if you can see the screen.
Yeah.
Yes.
Pretty.
Yeah, so there we go. We're going to answer some of Dr. Bruce's questions, and he only had one. Well, why won't it go? That's
because it's a demo.
Oh, all right. His question was how he, that's me, Thomas, managed to include so much processing in his work. He says he liked the articles that I'm writing on Simone, the robot you're seeing there. And my explanation to that is quite simple. I'm using the ARC IDE from Cynthium. And is it a real IDE? Well, that's debatable, but it has all the components of an IDE. It's not a compiled program, it's scripted, but it works fast enough for my purposes. Cynthium used to be called Easy Robot. They split off from Easy Robot about a year ago. So to answer his questions, A, I'm not using ELIZA. B, Alice is integrated into ARC. Let's call it ARC. OpenAI's GPT-3 was available, but he pulled it. It used to be there as a skill. It's no longer there as a skill. IBM Watson is available for Voice IO, but I'm not currently using it. I found something better. Microsoft Cognitive Services is integrated into ARC. Microsoft Cognitive Vision, which reads text, the text and identifies objects, is also integrated into ARC. Bing voice recognition is integrated into ARCs, as is SiteHound and YOLO Darknet. Those last two are both for identifying and classifying objects in any scene. And the other functions, well, I can tell if a face is there. I can follow a face. I can follow a color. It has speech synthesis. It has sentiment. It can read your emotional state based on what you are saying, which is converted to text. It can read your emotional state also based on a camera, your face. It can identify a face. It knows my face. It's learned it. My face is on a database somewhere. I have no idea where it is. I did not give it my full name. I can read most sensors like any IDE. It can read the Connect body, the Connect for body positions from the waist up. And it has real-time vision training, but doesn't work so well, and a lot more. So if you want to know more about this ARC IDE, you can go to their website. That's cynthium.com/products/controls. And if we have time later, I can give a demo of the software. Otherwise, if there's no questions, I'm done.
Any questions for Thomas?
Now, ARC stands for Autonomous Robot Control Software. Wouldn't that be ARCs then?
Yeah. And I'm not sure, but in the Homebrew Robotics Club archives, there's a talk. I think if it's recorded, I haven't watched it myself, but the president
Yeah, I'll go back and look. It's DJ Schurz.
Yeah, DJ. I've known him for years.
Yeah. So if you want to know more, if that's available, people can watch that hour or whatever it is and get a real insight into who it is and who he is and what it, what
I think it was last year. It was really cool because he allowed us to log into robots that were up there in Canada and remote control them during the presentation.
Ah, yeah.
We did things with the robot. We picked things up and dropped in the hole or whatnot. And theoretically, we were training their AI doing these things. And I don't really understand what their well, I do. From what I understand, their pitch is that you've got these autonomous robots, but when the autonomous robots don't know or aren't clear as to what to do, some kind of trusted controller can go in that is a person and do remote control on whatever it is, and then the robot's supposed to learn from that. So it's kind of an interesting space.
It's like teleop learning from teleop.
Well, yeah. In other words, it's autonomous robots, but when they have trouble, your babysitter jumps in and gets it straightened out and then goes away again.
That's that whole technology they're using in to drive robots around for delivery. They have people in India taking over when the robot calls for help.
Robot babysitting is a thing.
Yeah, it's a hybrid system, autonomous with human backup. All right, so thank you, Thomas. That is a good update. It does so much. I wish I had time. I may have to look into trying it out at least a little bit, just because there's so much you can leverage from all the features they have in there. It's like a one-stop shop.
Yeah, it has everything. It's the way I see it. It's kind of like a little bit like ROS with a GUI on it. It has all these modules that it's calling skills or controls.
Although to be accurate, or it's Windows for sure, but I don't know. Does it run on Linux at all?
I don't know if it runs on Linux. It may be. He's expanding it to a lot of things. It will run. It will interface to a Raspberry Pi or an Arduino, believe it or not.
Yeah, so it can it handles microcontroller levels and full computers and everything. Just not 100% sure on all the OSs, but yeah.
And it has several chat.
Mostly Windows, but they're moving to Linux.
Mostly yeah. I would think Camp you would know because you do a lot of Linux stuff. And,
well, I always quiz people about the Windows stuff.
So, it's nice to have a GUI on top of all this. I know a lot of you like the low-level coding, but I like to have boxes and draggable windows and such like that.
Well, in a lot of cases, we have to make the GUI in our low-level tool, or to like ourselves.
I know. It's one more layer of problem solving.
Or you have to use command line. Like if you're in ROS, it's a lot of command line.
I posted the link to that homebrew club meeting with DJ Schurz in the chat.
Oh, thank you. That's great.
Yeah, here's some of the things it does. There's the cognitive emotion, cognitive phase, cognitive vision, darknet YOLO, which used to be a real pain in the neck to get that loaded and going. I had that running on a computer one time. It took me 3 weeks just to get it started.
Wow.
There were so many mistakes in how to load it up. You had to fix things all the way to get it going. It was a pain in the neck. And there's your Connect live stream, picture-in-picture, QR code generator, and it just goes on and on.
These things keep getting, it's changing over time. These things get new versions, and there's more of them every year, right?
Oh yeah, every year there's probably, I don't know, 5 to 10 new things.
they're leveraging technology that's out there, just like we would, as hobbyists, right? We go out and we download something and try to compile it and integrate it. That's what he's doing all the time, right? Bringing in most of these are not written from scratch, right? They're all from different sources, a lot of them.
Yeah,
a lot of it's this bottom-up approach too, where he wants like mere mortals participating in robotics, which is a good thing.
Yeah, exactly. So, you may think this is kind of a high level, or the hardcore programmers of us might, kind of think, oh, but what if I want control? I need my code. They have scripting in this, but it's certainly a great way to get introduced to all these different powerful things and having a GUI to interface with them. So
it's also good for people who make robot replicas. I noticed we have a person here today who I haven't seen at the club before. Mike Senna. Are you still here, Mike?
Yeah.
Here?
Yes, I'm still here.
Hey, Mike. Good to see you. Mike's one of the best makers of robot replicas anywhere. He made a unbelievable Wally, and R2-D2 and BB-8 and an Eve, and his robots are impeccable. His robots have been on the red carpet from time to time. He is one of the best around. And Mike, this software might be something you could utilize pretty quickly and get it working. It has like a soundboard. It'll run MP3 bits of text and whatever you have. You want BB-8 to talk or R2-D2, you could use that.
I think they're kind of a big deal with the InMove crowd too.
Oh yeah, InMove loves this. Robot replica builders love this. Mike, do you have anything to show today? I know you've got wonderful robots.
No, I came in to finally have some time to visit with you guys and listen to what you guys were doing, and everything sounds so freaking amazing and a lot more than I've been doing. Of course, like you said, mine are for entertainment mainly. So it's I pay attention more to what the robot looks like and how it moves, the mechanics behind it. And I don't have too many autonomous things, but I do have autonomous things, transmitters and things that I build custom for triggering sounds and actions in the robot, but nothing like what you guys are doing. I'd love to get more into this kind of stuff.
Cool. Welcome. We're glad you're here, Mike.
Yeah, welcome, Mike. And we are not just autonomous, or we have a lot of people interested in the robot mechanics and the look and the finish, the finished product and how it moves. So you're welcome to please join us on another occasion and if you want to demo something, it'd be very well appreciated.
Oh yeah, we'd love to see one of your robots in action. Maybe next month, huh?
Possibly, yeah.
Well, that'd be great.
Because right now I was working on one of the Disney Plus Star Wars productions, with doing like a droid consultant was my title there, but we're wrapping up filming. So I probably had my last days on set this last week.
Well, so you've been really busy then.
Yeah, it's been a dream come true. It's crazy.
Wonderful.
We should have introduce him to Walter if he doesn't already know Walter Martinez, because Walter's, until recently, he was really heavily working on all sorts of Star Wars related robots, and he's for the last year and a half. So
I know Walter.
Okay, you know Walter. Good.
All right, well, that side of the robot world in Star Wars and entertainment robots is probably pretty small, as you guys probably know. in your circle as well.
Yeah. Walter's shown us pictures of the parties and events he's been to at the Builders Club, the Star Wars groups, a very exclusive group of builders, and it's very, very interesting.
Mike, are you still leading the R2 Builders Group?
Yeah, I am.
Oh, okay.
What are they doing these days?
Just the same old stuff. They've got some guys developing a really nice sound system for the R2s, where it's, I guess he's taking the different sounds of R2 from the movies and he'll classify them as a happy sound or a sad sound or whatever. And then on the fly, this thing will combine the different sounds to make new sounds. So if you hit a happy button, it'll play different versions of combinations of sounds of a happy sound. And that's pretty new, but it's on a phone. It's triggered by like a phone app and something else. So it's not really on board the thing, which I don't really like because the transmission range is Bluetooth, which lends itself to a lot of interference depending on where you're at. So it absolutely wouldn't fly for me, but I was thinking maybe I can use this app to create sounds and record them and port them into the sound boxes we use, or the sound cards we use. But that's the most interesting thing that's brewing up in the clubs.
Cool.
All right. Are you guys meeting in person, or are you still online like the rest of us?
Yeah, nobody's meeting in person.
Yeah, I hear you.
All right, well, let's get to Les for his demo as we get towards the last half hour here.
Okay.
Yeah, I'm sorry, guys. I'm going to take off too, so I will see you guys later, maybe next month.
Yes, please come back.
Have fun.
All right, bye-bye.
Thank you. All right, Les, yeah, you have the floor.
Okay, I'm gonna bring up this, share my screen. Yes.
Oh, Thomas, you might want to stop sharing.
I'm sharing, sure. There, sorry about that. There we go.
Okay, I'm just going to do this from inside of my Impress version here. Can y'all hear me okay? I understand my speaker doesn't seem to be, my microphone doesn't pick me up well.
It's all right, Les.
Yeah, we'll put up the volume a little.
Okay, so QB, I say now it's a humanoid robot, maybe. I've been struggling with this thing, as you all know. But so where is QB? What's happening? What's being added, and why has it taken so long? So QB's currently in chunks. So I've got one piece here, which is his main body and stuff that I can show you in a few minutes. The legs and arms currently aren't on him, and I haven't got him wired back up again. But it's because I'm on iteration 3 of his body and so forth. The reason is because when I began working to make him get up and walk, he couldn't. I had forgotten to put a pivot joint for the hip to get a setup motion. So that was a problem. So there was missing joints and I had to redesign them. And in the process, I figured out that I also had problems with monitoring the battery voltage because I didn't have an ABC. I didn't have any audio input or output, and I don't have a camera on it. So those are the pieces I needed to add. So what's happening? Well, with the realization of missing hip joints, I needed an A to D for the battery, a speaker, an amplifier for the speaker, a microphone, some additions and software. So I purchased some modules to do parts of that, and I'm beginning to work on the software to do that portion. And that means that QB needed a real redesign, and so that meant a larger body space, a larger connect box, and a few other pieces just to make it a little easier to work on. So what's being added? I chose an amplifier from Velleman using an LM386. I'm going to power it with one of the BECs. I chose an I/O microphone board which produces about 145 millivolts peak for the audio input. I can feed this to one of the A to D channels and go from there. On the A to D board, I'm dividing the voltage from the battery by 3 to put it in a range of 2.8 volts for conversion by the 3.3 volt ADC. And I have a small speaker, it's pretty weak, so I've got to figure out if that amplifier is going to actually do the job or not. So I've been breadboarding some stuff and playing with that. And then, of course, the hip joint, which started this evolution. So like all things, I'm distracted by shiny bits. So the missing joints. To get the hip to swivel up from the body, the new joint had to be embedded beside the motor driver board. This necessitated that the hip joint piece itself has to be a shorter design, and so that meant a redesign of the arm bits that tied to the servo for that particular junction. And those bits are shown here on the next slide. So what I had to change was a spacer had to be added, and then these gray boxes now are the servo receivers where the servo box will plug in. And then I had to leave a little space here so I can get the arm up over that post. And the studs are, of course, are what part of the mount for the next servo boards that go in to control the servos. And based on information that I got on here, I went from using melted points to putting in studs with holes in them, and I'm using screws to mount the boards now. So this is what a hip pivot has to look like now. And because they're different, I labeled them left and right so I'd make sure I got the right one in the right place. And so you can see the red part's the servo box, and you'll notice how the arm piece here actually goes down inside the servo box a little bit. And the small yellow bar down here is what goes in to connect it. And the reason it has to be in two parts now is because it's too short for me to use the technique I was using before to kind of snap it over there. But it's this short, it would break before it would have been far enough to snap over the post. And then because of restricted space, when I get it all fitted together, I had to be able to slip the servo arm down inside that hole in the box. So the end of the servo arm piece here, I had to remove the back side of it so that the servo arm can just slide in there, and then I use a screw through the hole to hold it in place. And then the pivot bar is slipped over the pivot and glued to the box. Then a completed assembly looks like this. This looks at the back of the robot. This is the main cover for where all the interconnects are and the various extra pieces I've had to add. Electronics, the green boxes are the battery compartments where I have two 18650 batteries in each. And then down here you can see what it looks like. The gray part is the servo. This right here is the actual piece we just looked at, mounted in place. And this is looking at it from the front. This hole here is where the speaker will be mounted. This hole has a fan mounted behind it, and this is just a vent hole to let the fan air circulate out. Now that I'm thinking about it, that probably should have been up here in this corner someplace because the air is going to be warm. I'd probably ought to ventilate it from the top of the box, but we'll see how it goes. So what this does then is this piece here can now pivot up 90 degrees in front of or behind. And that gives me the ability for the robot to sit down. That's what this whole evolution was about. And so the software, of course, simulation is still not working. I'm having difficulty getting all the joints to hang together. As soon as I turn on Gazebo's simulation mode, my robot falls apart in various places. But I'm working on that. I discovered that driving all the servos for balance and walking is very difficult. The robot has a total of 22 degrees of freedom just to walk and swing the arms. And as you know, when we walk, we swing our arms to help maintain our balance. Well, you have to figure out all of that. And that's a much more difficult programming task than you might think. As you're going to find out when you add an arm to Big Orange, you're going to find that things change a lot when you start moving an arm around at the end of a pivot. And the software for voice, both hearing and speaking, that's going to take a lot. I learned a lot today. I like the versatility of the web-based stuff or the cloud-based stuff, I should say, where you're using a lot of high definition stuff. But the problem is, if you've got a robot, you don't know that the web is always going to work. I mean, right here in my house, I can go to dead spots and I don't have any web connection anymore. What happens if your robot runs into a dead spot and you're trying to give it a command? So I really like that presentation on the HMM. I think that's a real way to go. I worked with that a long time ago a little bit, but my computing power wasn't what it is today. So maybe I'll be able to get back on that and try it. And that'll have some advantages for hearing. But for speaking, I'm just not sure what I'm going to do there yet. All of the speaking software right now is chatbot based. And I'd like to not be chatbot based. I want something like a hidden Markov model for the hearing. And I'm going to have to see what's out there for that. And my camera mount. I have about 6 different cameras here, and I can't figure out how I want to mount them to QB because I didn't think about putting it in the head when I first designed the head. And I really like the look of the head that I have now. So what I'm kind of thinking about is maybe doing something with a small camera that would be like a GoPro on a helmet, maybe a top knot on my watch. So that's where I'm at. I've been on this thing for about 1.5 years. I kind of took a break for the last couple of months. We had a death in the family and it kind of took the wind out of my sails for a little bit. But I'm getting back on the horse and things are moving forward again. So I hope by maybe in a couple of months to be able to show you QB at least standing up and maybe walking a little bit and maybe even be able to get him to set up and lay back down or a few other motions. That's it. Any questions?
Hey, Les, the Homebrew Club had a great presentation last Wednesday on control loops and so forth. I just posted a link in the chat. I think you might find it interesting.
Yeah, I'm definitely going to look at that stuff too. I was in the meeting, I think. I believe
that's right. Well, you know, the paper and pencil was wonderful.
Oh, wasn't it? That felt like going back to college, graduate.
No, that guy's brilliant too. He's Chris Packlin.
Yeah, he's really great. Professor, he's like professor.
Yeah. Well, he's done a lot of things. He's tried to do self-balancing bicycles and stuff like this, and apparently he's had an epiphany with control loops. And I grasped about 60 or 70% of that.
Yeah, luckily I had taken that class. I mean, I had taken this course on Coursera for free, that control of mobile robots with this kind of funny Swedish professor. And I highly recommend that one. And then you could really keep up. But he tried to cover the same amount of information that this class takes at least 6 weeks, 8 weeks, and he covered it in 1 hour. So, you know, even I took the class and I was barely able to.
Well, and it was like it was off the top of his head too.
Yeah, but that, you know, that it's really cool stuff. I mean, I recognize it was just almost everything from that class. So if you want to take it at a reasonable pace, like 6 weeks, and then the class is the way to go.
I gotta say, working in the test industry and working with lots and lots of engineers, the ability to take something and reduce it down to just the kernel essentials and explain it in a way that makes it simple is a real talent. And he had that ability. He took a very complex subject and reduced it down to just its essentials.
Yeah, he really did.
And that's just amazing. And he did it not only verbally and in demonstration to us, but he went through the math of how he got there. That was just, I was really impressed. I'm not even impressed.
Really, really well done. I mean, yeah, telling you what you need to know as a person who wants to use this stuff and understand it just enough,
Well, and we had some folks in the group that could keep him honest too.
Yeah, we saw, well, yeah, we saw him make he left out a term, and then in the next, that was an easy one to spot.
That was Michael Wimble. He's a Renaissance man.
Yeah, and then oh, you mean who spotted? I spotted it too, and I'm like, should I say anything? And I didn't, then I was trying to agree. And then well, Les spotted something with the Matrix boxing at the end. I didn't even quite, I'll have to watch that. That video is worth watching again a few times.
Several times.
I was going to ask, Kemp, is that meeting recorded then and available to see?
Yeah, it should be up now. I think.
Buzz, I just put it in the chat.
Yeah. Okay. Thank you. Yeah, I highly recommend that. He's a really wonderful speaker, and with the old school overhead camera with the pencil and paper, I mean, you can't get any more old school than that.
No, it had a real visceral feel to it, pun intended.
That's the way I was used to being taking courses in grad school and college, was still someone writing it at human speed.
What's the overhead projector?
Yeah, and it's this. There's a reason they do that, right? They did that. Or I don't know what they do today, but
it's PowerPoint.
Yeah, PowerPoint. It's better. It does really do something when someone's doing it at a human speed. Of like, you can watch them writing it. Actually, I do know what they do to some degree, because I've taken these Coursera courses, like with on AI or on machine learning with Michael the the guy from Stanford, and Ning, and he writes stuff. He brings up PowerPoint and then he writes it as well. So that is a common way, but anyway.
I couldn't do talks to test engineers without the greased front pin and the overhead projector slides. It's the only way you can really do it. And I had to have a whiteboard so I could expound on points and stuff. And it's hard to get that dimensional interface over a computer screen.
Yeah, well, and he did a good job though with the overhead.
Yeah. Like I said, all in all, just absolutely fantastic. The information, the ability to express it, and the concept that he showed us was just truly amazing.
Yeah, and like I said, I took this course, and at the end they show the Now robot. Remember, the Now humanoid robot. That's the small, it's a small version of Tepper.
Yeah.
And that one, at the end of this course, they use the same math, the same code, really, to control the joints of the arms and be able to, to do something with the arms, with the different joints. And so, that the applications are really numerous for control theory like that on robots, especially even for roving robots, like or ground-based floorbots, as we call them, to avoid obstacles and to make an optimal path using both wheels and a turn radius and all that. Anyway. Oh, Les, you're showing the actual thing.
So I wanted to show you. I meant to do this at the end of the presentation, but this is the new hip joint, and you can see that it has sufficient freedom to go backwards and forwards. And then the next servo down gives me the angular, like to do a split.
Oh.
So I've gotten that much on it. The other pieces should all just fasten into this. Knock on wood, as I say. But I had to add 2 more servos to get to this. So that means that the right now I have two 16-channel servo boards that are going to go in there, and I'm getting pretty close to full. I'm at 24 servos now between the two the head nod and the head turn. And then, of course, these do the shoulder turn, and the arms will hang down from here. It's just not as good a joint as you might get with a Revolute joint that would be a dual directional, but it'll give me the motion that I need, I think. And I've also used the servos are 250 to 7 degrees, so it can actually give a throwing motion. I don't know if it'll be fast enough to actually throw anything or if I'll ever be able to balance it well enough to do that, but the capability's there.
What's the torque on those servos?
It's 20 kilograms per centimeter. So they're pretty healthy. They'll break plastic joints if I let them go too far.
Les, another thought about your cameras. If you put them in your head, there's those little ESP32 boards that have those miniature cameras on them. So if you're space constrained, those might work for the head that you're working with.
It's not just space, but it's also weight. That's a terrific idea. Those will be a lot lighter than what I have.
Plus, you have the ESP32, so you could put local processing in there to process some of the video off those cameras.
Yeah, that would be really great.
And I don't think they're very expensive. I think they're around $25 or so on Amazon or something like that.
Yeah. And so when I got into that spot, that's a drop in the bucket at this point. And I know you guys have got a lot more expensive bots out there, but for me, this one's been a stretch. But that's a good point. I'll try that ESP32 camera. I can build a little box. That's easy to do with the 3D printer. Like I said, I think the only choice I have is GoPro style. Put a top knot on my bot with the camera in it.
Oh, it looks great, Les. We look forward to seeing all those servos firing up at once.
Let's not use the word fire. I'm a little sensitive about that right now.
Oh, I'm sorry. Bad choice of words. Yeah, that can happen. Yeah, geez. All right. Well, we're reaching the top of the hour. Anybody have any last any comments or questions for Les? And I think that he was the last one.
Good.
Who's that?
I actually had a question for Alan.
For anybody, yeah, that's a good point.
And I can't read the AI pile files in a Windows machine. It's Linux only, and all my stuff is under Windows. Is it possible you could upload the files onto a Google Drive uncompressed so I can get to them?
Yeah, I haven't downloaded them yet, but that's certainly an option. I'm a little bit confused about why you're not able to download them or unable to unarchive them. What's going on?
I'm unable to archive them. They're in a weird ZST format that I don't have any Windows utilities that know what to do with that.
What about 7Z or 7Z?
7-zip doesn't recognize it either.
Oh.
Well, that's fine.
Oh, those weird, yeah, those weird files. I had that same problem, and what did I do? I think I used I might have used like a Sigwin window or on Windows or a MSys, like, you know, lightweight, or I might have used Bash. Yeah. Because, you know, you can get Bash on Windows, like with Git Bash and or install MSys too, and you have a very lightweight ability to do Linux commands. But that particular decompressor might be available for Windows too. I'm not sure, but yeah, I think everybody should have everybody should on Windows should at least have the Windows System for Linux installed. It's really these days it's really nice to have that, or at least get or like MSys2. MSys2 is really lightweight, and it has bash and with Mingua. It's the Mingua, so it's a very lightweight shell, bash shell, and you can install various Linux type of applications in it with a command line, with like Pacman. So you can, and then, you know, it's all sharing the same disk. It's on the same file system and everything. But either of those two is a great way.
Okay, I guess I'm gonna have to knuckle down and install one of those then.
Yeah, I don't know if you're, because I'm a Windows guy, but I'm also, you know, we're all like, most of us have a little crossover between Linux, Windows and Linux, or at least having some command line Linux thing on your machine. Even if it's a lightweight shell, it's not a whole operating system or anything. Yeah, okay. All right,
yeah,
well,
we've got a couple of options, yeah.
Yeah, I personally highly recommend every Windows user should have it could easily use the Windows system for Linux. That's built in. You could just install it with the option in the optional Windows subsystem features, the feature installer for your Windows 10. And yeah, I'm going to try to do a whole ROS2 thing with the Windows System for Linux version 2. Anyway, I guess we're passing 12 o'clock, and I want to end the official meeting and stop the recording. And thank you for everybody participating in the show and tell. And it was very good. We never know who's going to go have a prepared PowerPoint. So thank you, Les. And thank you to all the other ones.
I looked online and it said I had a presentation today, so I whipped that up real quick.
Oh, nice. It proves you can type into PowerPoint pretty quick.
Thank you, guys. Had fun. See you next time.
You bet.
All right. Thank you.
Bye, guys.